Okay, guys, so this afternoon, okay, this is going to be the second part of this afternoon's lesson, okay? So we're going to take a look at ratios and Pythagorean theorem questions, okay? One thing to note just before we go any further, we're not going to worry about this particular question up here. The solution I had was very crude and oversimplified, and quite honestly, it didn't make 100% sense to me in terms of what was done. I didn't like it. I didn't agree with the math that was in it. So when I went to go look for an example in the textbook didn't do this kind of question either. So we're not going to worry about this. In looking up some solutions, it's actually quite complicated. And for the purposes of a short summer school course, we're not going to worry about this, okay? I think some of these other related rates questions are complicated enough. We don't need to just go absolutely crazy with this kind of question, okay? So don't worry about those kind of questions for now. Okay, why don't we jump down and take a look at the Pythagorean theorem question? Okay, and what we can do is we can draw basically what's going on here. Okay, we know we have a ladder that's 4 meters long. Okay, and it's leaning up against the wall. We'll call this our wall. And the ladder, try to draw it as clearly as I can. Here's your ladder leaning up against the wall. It's 4 meters long. Okay, your ladder. This isn't going to cooperate. Okay, so here's your ladder, and it's 4 meters long. That almost looks like 21. It's a 4. Okay, 4 meters. We want to find out. Okay, there's a couple things going on. So if the bottom of the ladder slides away from the wall at a rate of 30 centimeters per second. Okay, so we know through convention that this is always typically the C value, okay? And we're going to call, I don't know, for argument's sake, this is going to be A, and B is going to be here, okay? So we know, based on what it's telling us in the question, dA by dt, so the distance relative to time is 30, okay? That's this number here, 30 centimeters per second. That's dA by dt. Okay, I'm just going to try and label as much stuff as I can on here. Okay, we want to find out how quickly the top of the ladder, so basically dB by dt, it seems like, is sliding down the wall when the ladder is 2 meters from the wall. Okay, so there's a lot of stuff going on here, but we basically want to find out, if the ladder is 2 meters from the wall, and looks kind of funny here, not the greatest diagram, but we're just using it to put information on here. Okay, if the ladder is 2 meters from the wall, and it's moving at a rate of 30 centimeters per second, right? What's happening here? That's what we want to find out. Okay, so that's that. I would label like, and the other thing, sorry, I suppose you could say the length of the ladder is not changing, right? So we would say dC by dt would equal 0. Okay, so I think this diagram has taken care of most of what we need. I'd say now we could go and write out Pythagorean theorem. Pythagorean theorem tells us that a squared plus b squared is equal to c squared. Okay, if I were to implicitly derive this, okay, I would see 2a, and remember with chain rule it's telling us that we have to go dA by dt plus 2b dB by dt has to equal 2dC by dt. Now the catch here is, though, we know that dC by dt is equal to 0 because the length of the ladder is not changing. Okay, so we're going to end up with, I won't scratch that out, I'll say 2a dA by dt plus 2b dB by dt has to equal 0. Okay, now hopefully we could try plugging in some stuff and see what happens, right? I think, if I were to go underneath here, it looks like, what is it I'm interested in? I'm interested in this. How is the ladder moving down the wall? At what rate? Okay. If I'm examining everything here, I know how far it is from the wall. That's the 2. I know the rate at which it's moving from the wall. That's dA by dt. The problem is I don't know b at the moment. Okay, but that's not an issue, right? Initially, I was worried there, but I'm not worried now because we can use Pythagorean theorem to find what the length of b would be in the event that the length of the ladder was 2, or that the ladder was 2 meters from the base of the wall. Okay, so we can find what b is using Pythagorean theorem, right? We're going to say, okay, well, 2 squared plus b squared has to equal 4 squared, right? And so b squared is going to equal 16 minus 4, and b would equal the square root of 12, if I'm not mistaken. Okay, so there you go. We know what b is equal to. We can plug that in there. We now know that too. Okay, so let's do a little bit of isolation. Ultimately, for the thing that I want to know, the rate at which the ladder is moving down the wall. Okay, and we'll say, here we go. Okay, we're going to move this whole term over to the left side, and we're going to see that 2b, I'll write it in black. We're going to see that 2b is going to, 2b dB by dt, right, has to equal negative 2a over, 2a, this is new to me, this is a little tricky, guys, dA dt. Okay, and then I can divide both sides by 2b. So dB by dt. Now, something to be aware of, and this is just this is my physics background kicking in here. Okay, look and be careful with what's going on here, particularly around the units. Okay, you've got centimeters. I would say the rate, to convert that rate would be a little bit trickier, right, than to just switch 2 meters into centimeters and 4 meters if we needed it in into centimeters as well. Now the catch here is maybe B, our problem might run into B here, so I'm just going to go, I'm going to switch B into, B is going to equal the square root of, it would be 1200. Sorry guys, I'm just thinking here. Sorry, we might have to backtrack here for a sec. This is my bad, I wasn't paying attention to the units. What we're going to do here, let's backtrack. We'll resolve for B here for a sec. Okay, we'll go A will equal 200, right, in centimeters, 200 squared. C will be 400 squared. It might still be okay, actually. I just wanted to be sure. So B squared would equal the 400 squared. What's 400 squared? No, we would have been wrong, which is good. Okay, we're going to get 100 and 40,000. Okay, and B would equal the square root of so B is going to equal 346 centimeters. Okay, guys, so just be careful. Okay, you know, you can't just be mixing units around like what I was going to. I wasn't being sequential, but at least when I got to this stage, you know, as I'm thinking about plugging in my numbers, and I come to the realization that, you know, the dimensions or the units have to work out at the very end. And if you've mixed meters with centimeters, that's not going to work. I mean, you could have changed dA by dt into meters per second as well. I mean, either or will do. I'm not going to specify at the very end what to do, right? Like how you want to express your answer. Okay, so here's where we're at. Okay, we now know pretty much everything here. Okay, we know the fact that A is 200 centimeters. Okay, so we're going to say -2 times A is going to be 200, and that's in centimeters, right? And dA by dt is going to be times 30. And then we need to divide that by 2 times whatever B was, which we found to be 346. Okay, and we'll find that dB by dt, if I type this into my calculator, we'll see that's, let's see here, dB by dt. So let's just type this all in. See, -12,000 divided by whatever that would be. Okay, 692. And so at the current, when we do the math on this, when the ladder, at the specific unique moment in time when the ladder is 2 meters from the base of the wall, we're going to see that the ladder is moving down the wall 17.34 centimeters every second. Okay, that's how quickly it's moving down the wall. Okay, when it's 2 meters from the base of the wall. Okay, so that's it, guys. Just a couple little, something. The equation itself looks a little bit easier than some of the stuff we did this morning, but just be careful in what the information is that they provide you. Okay, because that's going to affect your answer at the very end. Okay, I don't really care. That's not unreasonable to. That's almost even more conceptually easier to picture relative to, like, what a ruler would look like, right? 30 centimeter ruler, that would be like half of a 30 centimeter ruler every second. That's how quickly that ladder's moving down the wall. Conceptually, if you left that in meters, so might have 0 point whatever it is meters. That's a little bit. I know you're going to make the conversion to centimeters anyway. Okay, in your head to contextualize the answer. So anyway, that's that, guys. I'll hit stop there. That's your Pythagorean theorem question. How you would tackle something like that. Remember, you're always just deriving things with respect to time. Okay. And in the event that there's no time variable, which is at the heart of implicit differentiation, if there's no variable to derive, then you derive what you have with respect to that variable that you're looking for, okay, dt. All right, so I'll see you in the last part of this question. Again, don't worry about the hemisphere questions. They're more complicated than I originally thought, and they're definitely more complicated in the way that I got shown in high school. And they're not even in the textbooks. Don't worry about those questions, okay? So we'll do like kind of a ratio question down here at the bottom, and then that'll wrap it up for related rates, and we will move into finding derivatives of exponential functions and trig functions, okay? So that'll be pretty much the rest of this unit, and then we'll start the vector portion of our course, okay? So I'll see you in the last part of the video.